Scientists plant a tree on Mars and make the biggest forest. Is it really will be possible? Let's dig out together. Stay tuned. Hello and welcome to Z. Don't forget to subscribe and click the bell icon. NASA has achieved a level of reliability that allows it to produce oxygen on Mars sufficient for one tree. The distance between the International Space Station and Earth is only 248 miles, which is little further than the distance that must be traveled by car to get from New York City to Washington, D.C. Everything that they require can be provided to them in a reasonable amount of time. When astronauts travel to Mars, they won't find it as easy to get around. The average distance between the Earth and the red planet is around 140 million miles. It is possible for us to schedule supply runs, but it would be prohibitively expensive and impossible to bring everything along with us. It will be necessary for explorers to learn how to subsist off the Earth, just like Mark Watney did in The Martian. There have been many suggestions made regarding how astronauts might generate the necessities, but up until very recently, none of these technologies had been put to the test in the real world. We are now in a position to claim with absolute certainty that people will be able to produce oxygen on Mars thanks to a device known as MOXIE that was constructed by MIT and stowed away on NASA's Perseverance rover. In a paper that was published this week in Science Advances, the researchers said that 7 experimental runs that lasted an hour each and took place throughout the year 2021 demonstrate that MOXIE is capable of reliably converting carbon dioxide into the equivalent amount of oxygen produced by a small tree. In testing that spanned various temperatures and pressures, day and night, winter and summer, the stalwart machine steadily sucked in Martian atmosphere and breathed out at least 6 grams of oxygen an hour. These tests occurred during the day and night. MOXIE accomplishes its extraordinary feats by drawing in air, removing dust using a filter, compressing the gases, and heating them to 800 degrees Celsius. When the air is heated, it passes through an equipment called a solid oxide electrolysis device, which breaks down carbon dioxide into oxygen and carbon monoxide. Carbon dioxide makes up 96% of the atmosphere of Mars. After that, the machine separates the oxygen from the carbon monoxide and releases both of them, together with a number of other gases, as the exhaust. According to MOXIE Deputy Principal Investigator Jeffrey Hoffman, a professor of the practice in MIT's Department of Aeronautics and Astronautics, this is the first demonstration of actually using resources on the surface of another planetary body and transforming them chemically into something that would be useful for a human mission. This was stated in a release. This is the first demonstration of actually using resources on the surface of another planetary body. A so-called forest on Mars. The demonstration is just the beginning of the process. A future model, which would have the dimensions of a small chest freezer and produce oxygen at a rate comparable to that of several hundred trees, is already in the works. The machine is capable of producing around 3 kilograms of oxygen every hour over a period of 26 months. This oxygen can be stored in a tank and used to keep astronauts breathing as well as fuel their return home. To get there, the machine would have to demonstrate that it is capable of running continuously in the hostile climate of Mars, and it would require a significant amount of power. According to Dr. Michael Hecht, associate director at MIT's Haystack Observatory and main investigator on MOXIE, power is the area where we expect to see the largest improvement in the scaled-up MOXIE. This information was shared with Singularity Hub. On the Perseverance, we utilize up to 300 watts to create approximately 8 grams per hour of oxygen, which indicates not much more than 10% efficiency in relation to the amount of electrochemical power that is actually required to tear apart the CO2 molecule. According to our in-depth analyses, we anticipate that the fully operational system will have an efficiency of closer to 90%. According to Dr. Hecht, some of these benefits will be accomplished as a result of a larger machine's ability to operate at lower pressures, hence saving energy on compression. However, the most of the credit will go to economies of scale. For instance, the same electronics can be used to manufacture either grams or kilograms of a product. Of course, it will still call on a dependable source of electrical power. Dr. Hecht believes that a nuclear reactor with the ability to produce approximately 10 kilowatts, which is now being built by NASA, should do the trick. Going the nuclear route offers both reliability and longevity as a bonus. Opportunity, a solar-powered rover operated by NASA, was destroyed when a global dust storm blocked the sun's rays from reaching its panels. On the other hand, the nuclear power source of the Perseverance is completely self-contained and has a lifespan estimate of 14 years. When we talk about dust storms, we should mention that for a machine that makes its livelihood by sucking in air, global storms that continue for weeks or months would appear to be dangerous adversaries. In point of fact, according to Dr. Hecht, the identical thing that you would anticipate to happen to the air filters in your home would occur on Mars. Dust filtration is an area that has received a significant amount of attention from our research, and it appears to be one of those situations in which Mother Nature is on our side. He explained that the storms themselves were not nearly as big of a concern as the continuous ingestion of dust. The dust, however, does not follow the airflow as easily at such low pressures, which is fortunate since it allows nearly all of it to be removed by using straightforward baffles that direct the air to go around corners as it is sucked into the system. Even though significant questions have been addressed, the MOXIE development team intends to keep testing the software. They want to operate it during the times of day on Mars when the temperatures are at their most volatile, drive it to produce more oxygen, and closely monitor its level of wear and tear. In the meantime, back on Earth, the business that was responsible for creating the electrolysis unit, Oxyon, has already constructed and tested a system that is 100 times larger. Where do we go from here? It is difficult to predict how quickly we will require a final product. This year, NASA intends to launch Artemis I, a spacecraft that will serve as a stepping stone on the way to the Moon and, ultimately, Mars. In the meantime, China is interested in exploring the Red Planet, and SpaceX is working feverishly to finish developing their Mars rocket. The estimated time of landing is somewhere between the latter part of this decade and the middle of the 2030s. In the time between now and then, we will have to find solutions to a number of critical problems. However, one of the most important things to do is figure out how to create the oxygen you breathe and the gasoline you need to get back home. According to what Hoffman told the Washington Post, it's what explorers have done since the beginning of time. Find out what resources are available where you're going and learn how to use them, the travel guide advised. This is all for now. Thank you for being with us.